Welcome to November 2020 question 3 of paper 1, where we ask questions that are concerning sigma notation. Very interesting questions indeed. Now let's go ahead. We know that sigma notation goes hand in hand with geometric sequence. So let's go ahead and deal with this one. 3.1 said prove that sigma when k is equals to 1, 4 times 3 to the power of 2 minus k is a convergent geometric series. Show all calculations. Okay, all right. So let's come here and say, okay, no, 3.1. 3.1, we're given that's our series there. K, you are starting at 1. Be careful, guys, here, né? Right here. You need to be careful here. Sometimes they will say K start at 3 or K start at 2. Okay. So you need to be very careful here so that you start properly. Okay. All right. So it's 4, 3, 2 to the power of 2 minus K. All right. Okay. Now let's go ahead and have a look at this one. T1. T1 will start when K is equal to 1. Okay. T1 starts when K is equal to 1. Right. So with that, let's substitute. Is going to give us 4, 3, 2. Okay. When K is equal to 1, so it's going to be minus 1. Therefore, T2 will start when K is equal to 2. Okay, same thing applies here. We're just going to substitute into the formula 2 minus 2. Okay, therefore T3 will start when K is equal to 3. Therefore 4, 3, 2 minus 3. Okay, so if you put this in our calculator, we should get 12 there. And therefore, because it's a series, I'm going to put a plus there because this is a series. Okay, and then 4 plus, and then the third one is 4 over 3. That's our third term. Okay, right. So we know that in terms of the ratio, in order for us to prove convergent, let me just put it here. In order for us to prove convergent, you can have a look at it in your formula sheet, guys. Our R value needs to be less than 1, but greater than -1. Therefore, it means this series is a convergent series. Okay, so let me come here and say R is going to be equals to T2 all over T1. Okay, so T2 is 4 all over T1, which is 12. This is going to give us 1 over 3. Okay, so definitely if R is 1 over 3, it means our R is less than 1 but greater than -1. So therefore, it is true that this series is convergent. It is true that this series is a convergent series. Okay, so now let's have a look at 3.2. 3.2 says if we have got the sigma notation where k is equal to p, 4 times 3 to the power of 2 minus k is equal to 2 over 9. Okay, because now here we have got an infinity here. All right, and we already know what is R. Okay, so we need to go ahead and be able to deal with this one. Okay, all right, let me come here and say let's move to the next page so that we can have a space. All right, so now if you come here, you can substitute here. Let's see what we can substitute here. All right, let's look for determine the value of p. Okay, so here this value here refers to the sum because we're dealing with sigma notation. So but the sum to what? The sum to infinity. Okay, so it means s to infinity, we're doing 3.2, s to infinity is equals to 2 over 9. Okay, So, but what else do you need when you deal with the sum of infinity? The general formula of sum to infinity on your formula sheet, on our formula sheet rather, it's given by sum to infinity a is all over 1 minus r. Okay, so therefore we need to find the value of a. Okay, the value of r, we did calculate it previously, is still going to be the same. Nothing would change here. It's 1 over 3. But if you would like, you can still put the value of p there, substitute. You should be able to get to the same thing. All right. Okay. So now let's look for the first term. The first term in this case, it would be a. It's equal to, let's look for the first term, 4 over 3, 2 minus p. Okay, because we're starting at p there. So that's our value of a. Okay, so we can come to our equation and substitute all these things together so that we are able to find the value of p. Okay, sum to infinity is 2 over 9 is equal to a. It's 4 times 3, where 2 is the minus p, all over 1 minus 1 over 3, which is our r there. Okay, right. Okay, so now what we can do in this case, we can cross multiply. Okay, we need to cross multiply. Okay, therefore cross multiply, let's assume that this is over 1, cross multiply, therefore 4 3. Okay, 4 3, 2 minus p is equal to, if you say 2 over 9 multiply by 1 minus 3 on our calculator, let's punch that directly into our calculator. We can see that is going to give us 4 over 27. Okay, okay, no, great stuff. So now what we can do now, we need to divide by 4. Divide by 4 both sides here, divide by 4. And then this, in this case, let me rather put it like this. Oh, okay, sorry about that. Let me go back. In this case, let me rather put it like this. This case, let me say multiply by 1 over 4. Okay, 4 and 4 would cancel out, 4 and 4 would cancel out. Therefore, we're going to be left with 3. It's going to be 2 to the power of minus p. It's equal to 1 over 27. Right, this is taking us back to the exponents. So because I'm running out of space, I'm going to just write here. Therefore, we're going to have 3 2 minus p. This 27 we can change to 3 to the power of minus 3 in terms of exponents. Okay, so now if you've got exponents here, the bases are the same, therefore the exponents should be therefore be equal. Okay, so the exponents here is minus 2 minus p is equal to minus 3. Therefore, you take the 2 to the other side, it will change the sign. Minus p is equal to minus 3 minus 2, which is going to give us minus p is equal to minus 5. Therefore, you divide by minus 1 on both sides. P is equal to, therefore, 5. All right. Okay, you can put this p into the equation and double check if you will get the same sum. You should be able to get the same thing. I am Gaston Mapala. This was question 3, November 2020. See you on the next upload where we will be doing question 4, November 2022, 2021, and 2020. Stay tuned. Make sure you subscribe so that you don't miss out on any future uploads.